We are still on 5.3 function families. Today we're going to start the absolute value function. So everything you're going to know is in this family, function family. It's going to be easy to identify because it's going to have an absolute value sign. So that's going to make it quite easy to kind of identify. So absolute value function. It has an absolute value sign. Here's the general equation. I'm going to skip over vertex right now. We're going to come back to that. And then you're going to connect with straight lines. But this time, it's going to actually make a V. So whenever you make an absolute value function, it's going to make a V. Now, an absolute value function has reflective properties, meaning it's going to be reflective over a line, and so you're going to need to see one side and then the other. So in order to do that, you are going to have to test 5 numbers. Now I know before with linear we just tested 3, a positive, a negative, and 0. We're still going to do a positive, negative, and 0, but now we need to do 5 numbers. All right, so our very first one is y equals absolute value of x plus 1. So I'm going to test 5 numbers. I'm going to do my 3-column table right here, and you can do a 1 or a 2. I mean a 2 or a 3-column. It's up to you. So my input would be x. My actual function is the absolute value of x plus 1. And then my output this time happens to be y based on my problem. So I'm going to test 5 numbers, 1, 2, 3, 4, and 5. And usually my go-tos are, I try to keep it simple, -2, -1, 0, 1, and 2. So again, positive and negative numbers, keeping it simple. So I take my equation, absolute value, and then I'm going to put in, instead of x, I'm going to replace that with a -2, and then plus 1. So the absolute value of 2 is 2, 2 plus 1 is 3. Next one, absolute value of -1 plus 1. Absolute value of -1 is 1, 1 plus 1 is 2. Now we have the absolute value of 0, 0 plus 1. Absolute value of 0 is just 0. 0 plus 1 is 1. Now you have the absolute value, plugging in 1 this time, plus 1. Absolute value is 1. 1 plus 1 is 2. And then you have absolute value of, I'm going to plug in 2 this time, and 2 plus 1 is 3. Now I said there was a reflective property. You can see that this is kind of the center, and then you can see I have a 2 and a 2 and a 3 and a 3. So let's go ahead and plot these points. So as you know, it's -2, 3 I'm plotting. So at -2, 3, I make a dot. I have -1, 2, so -1, 2, I make a dot. 0, 1, I make a dot. 1, 2 is right here and I make a dot. And 2, 3 is right here and I make a dot. So I would use a ruler, but you're going to see that you connect the dots like so. And you can see it is a V. I connected with straight lines. That's going to be important once we get to quadratic. And there you go, an absolute value graph. It's always a V. All right, so now f of x equals -2x. So again, I'm going to make my 3-column table. My input would be x. My function is the absolute value of 2x. My output this time is f of x based on my equation. So I'm going to test 5 numbers. Okay, so my go-tos again are -2, -1, 0, 1, and 2, trying to keep it simple. So I do absolute value of -2, and I'm going to plug in 2, so times 2. And -2 times 2 is -4. Take the absolute value, and that would be 4. And of course, you can work these out on a different sheet of paper if that makes it a little bit easier for you. So -2 times a -1, and of course, you can use a calculator too. -2 times -1 is 2. Absolute value of 2 is 2. Next one, -2 times 0. -2 times 0 is 0. Absolute value of 0 is 0. Now, next one is -1, or excuse me, +1. So -2 times 1. -2 times 1 is -2. Absolute value is 2. And here you have -2, and we have times 2, which would be a -4. Take the absolute value, which would be 4. Again, here's your kind of center, and then you see the 2 and the 4 reflecting. So as I go to graph, I have -2, 4. I have -1, 2. I have 0, 0. I have 1, 2, and I have 2, 4. So again, makes a V. This one seems to be a little steeper, and we're going to talk about that in our next video for tomorrow. But absolute value graph. Now, I want to talk about this whole vertex situation. Let me pick up a different color to highlight. So vertex, it says A and comma B. The vertex is the very center. This is referred to the vertex, the point where those two lines, because if you covered up one part, you really just kind of have a ray, it's called a partial line. And then same thing here, this is the vertex. So this vertex right here is located at 0, 1. This, that center part, is the vertex. And here, this center part here, 0, 0, is the vertex. Now, I want you to look at this. It says the vertex is AB. So here, if I wrote my vertex, and maybe I'll pick up the orange pen so you can see it, my vertex would be 0, 1, because that's where this point is located at, 0, 1. This vertex would be 0, 0, because that's where it's located at. It's at 0, 0. Now, if you look at the formula, you can see it has an A here, a -A, and then a B. And so it relates to things here. And we're going to talk more about that tomorrow. All right, absolute value graphs.